Good morning, champions. Champions, will you be my friend? No. I'm not asking about myself. Carbon is saying that will you be my friend? As you all know that carbon is one and only versatile and unique element, and it is friendly indeed. It not only forms compound with the hydrogen, but it also forms compound with the other elements such as oxygen, nitrogen, sulfur, phosphorus, etc. So in today's class, we will discuss about the friendly nature of carbon, heteroatoms, functional groups and their types, naming the carbon compounds containing different functional groups. So with the start of the class, we are going to discuss about the friendly nature of carbon. As I told you that carbon is very friendly in nature. It not only forms compound with the hydrogen, it also forms compound with the other elements. The atoms of other element can be added to the hydrocarbon by replacing one or more hydrogen from it, right? So, carbon is very friendly in nature. Carbon is very friendly in nature. It not only forms compound with hydrogen, but it also forms compounds with the other elements, such as halogens, oxygen, nitrogen, sulfur, etc. So, carbon is not only versatile in nature, it also forms compound with the other elements, right? These elements other than hydrogen and carbon can be attached to the carbon compound especially hydrocarbons, carbon compounds by replacing one or more hydrogen atoms. So, any other atom can attach to the hydrogen to the carbon compound by replacing one or more hydrogen from it, right? Especially from the hydrocarbons, such as when chlorination of methane, when chlorination of methane is done in the presence of sunlight, one hydrogen is replaced from the methane and it becomes CH3Cl plus HCl. It is chloromethane. In a similar manner, rest of the other hydrogen can also be replaced. Why? Because chlorine is more electronegative than hydrogen. So it replaces hydrogen from the hydrocarbon and get attached to the carbon compound. Right? Now, the point to be noted is that when any element other than hydrogen and carbon bounded to a carbon compound decides its properties. Right. So this point has to be noted. When any element other than hydrogen and carbon bounded to a carbon compound decides its properties. It means, suppose oxygen atom is present in any hydrocarbon, then the characteristic behavior will be decided by oxygen, not by the presence of hydrogen or carbon. Right. So when the other atoms get attached to the hydrocarbons, it becomes boss and regulates the entire physical and chemical properties of the hydrocarbons, isn't it? That's why these elements are called heteroatoms. So what are heteroatoms? These are the elements, these are the atoms other than hydrogen and carbon. So all the atoms, you can say, it get attached to a hydrocarbon by replacing hydrogen from it. It means the elements other than hydrogen and carbon, which is attached to a hydrocarbon, is called heteroatoms, right? But examples of some of the heteroatoms are halogens, that is chlorine, bromine, iodine, fluorine, etc. Oxygen, nitrogen, sulfur, phosphorus, etc. So when these atoms, or you can say the atoms of these elements, get attached to a hydrocarbon by replacing hydrogen from it, it adds a specific property to the carbon compound, right? And it doesn't matter what kind of carbon chain it is. It is whether it is a straight carbon chain, branched or cyclic carbon chain, right? It add up. It means these atoms add up a specific characteristic property to the carbon compound to which they are attached. Now we will define functional group. So, functional groups are defined as the heteroatoms or the group of atoms containing heteroatom which decides the characteristic property of the carbon compound are called functional group. Right. So, what are functional group? Functional groups are the heteroatoms or the group of atoms containing heteroatoms which decides the characteristic property of the carbon compound are called functional group. You can say that it is true to say that, right? Just like Lord Krishna, which is present in every human being, you can say, but the characteristic property, it means deeds, karmas are decided by ourselves, right? Not by the Lord Krishna. So we are responsible for our karma. Similarly, when these heteroatoms or the group of atoms which contain one or more heteroatoms, right, attached to a carbon compound, the whole characteristic property is decided by these groups, right? That's why they are called functional group. As the name suggests, functional in nature. It means they decide the function, characteristic property of a carbon compound to which they are attached. Some example of functional groups, we will see it in detail. These groups are called functional group because when they get attached to any carbon compound, decide its property. We can say decide its function. And they are very specific in function, right? You can say when alcoholic group is added to a carbon compound, it shows a characteristic different property. And when carboxylic group is added to a carbon compound, it shows different characteristic property. So the functional groups are very specific in nature. The behavior of functional group. The function of functional groups do not affected by type of carbon compound or the length of carbon chain. What does it mean? It means that the functional group shows their function regardless of the type of, you can say, carbon compound or the nature of chain of carbon atom, right? That's why they're very specific in function. Now, we will discuss about some functional groups, right, specifically, and we will also try to learn how we can name them. Let's discuss about the different types of functional groups. Okay. We not only discuss about the functional group, but we also discuss about the heteroatoms present in those groups. So, heteroatom, nature of compound, and functional group. Starting from halogen, actually halogens are fluorine, chlorine, bromine, iodine. These elements, or you can say the elements present in the group 17 of periodic table, that is called halogen group, right? So all the elements are called halogen. So when halogen get attached to a carbon compound, especially to hydrocarbons, it becomes haloalkane. They get attached to the hydrocarbon by replacing hydrogen from it. So they substitutes hydrogen. Actually, they all want to share one electron to complete their octets, right? So by replacing hydrogen, they share one electrons with the carbon atom and become stable and establish a single covalent bond with the carbon atom. Now, this is the first. Remember the name of the compound, it becomes haloalkane. It will be useful while we start naming the compounds containing functional groups. Now the second is, the heteroatom is oxygen and the group is alcohol. It has wide scope uses in our day-to-day life, and the function group is OH. It's where oxygen is still has not completed the octet. So you can say the valency of OH, it means the number of electrons required to complete the octet is 1. So the oxygen atom present in OH group, that is alcoholic group, is attached to the hydrocarbon by replacing a hydrogen from it, and it get attached to the carbon atom by sharing electron. Now the third is, in the third functional group, the heteroatom is also oxygen, and it is called aldehyde. And the functional group is CHO. Oxygen is bonded by double covalent bond to the carbon, right? And still this carbon is not satisfied. It means if it want to attain the nearest noble gas configuration, it will share electron with other carbon atom by replacing hydrogen from the hydrocarbon. So it is aldehyde. Now the fourth one is, and the heteroatom present in the fourth functional group is also oxygen, carboxylic acid. And the functional group is COOH. COOH. We simply write it CHO, aldehyde group, and carboxylic acid, COOH. In carboxylic functional group, one oxygen is attached by double covalent bond, right, to the carbon, and OH is attached by single covalent bond to the carbon atom. So this is carboxylic acid group. Now the fifth and last one as per our syllabus, that is ketone. The functional group is CO. If we talk about the valency of this functional group, it requires 2 electrons, right? It means the carbon present in it requires 2 electrons to complete the octet. We simply write it as CO. And these bond lines suggest that it is open from both sides to share one electron. So, as per the CBSE syllabus, you have to study about these 5 types of functional group. Let us recap once again. The heteroatoms contained in this functional group is halogen, that is fluorine, chlorine, bromine, iodine, and the nature of compound is haloalkanes. Suppose methane is attached to the chlorine is attached to the methane, it becomes chloromethane. Similarly, when a chlorine is attached to ethane, it becomes chloroethane, and so on. Second functional group, it contains heteroatom oxygen and it is represented by OH. The nature of compound, or you can say the name of compound containing OH group, is called alcohol. Third functional group, heteroatom is oxygen, and the name of the compound which contains this functional group, that is CHO, is called aldehyde. The fourth one is carboxylic acid. In the carboxylic acid, the heteroatom present is again oxygen. It is represented by COOH, or you can say in bond representing the bond structure, it is C doubly bonded oxygen and bonded by single covalent bond OH. The name of the compound is carboxylic acid. Now the fifth one is ketone. So ketone contains the functional group CO. One oxygen is bounded by the double covalent bond to the carbon. Right. So these are the 5 functional group. As per the CBSE syllabus, we will study about it. Now we are going to discuss about naming the carbon compounds, that is hydrocarbon containing functional groups. So we will start with halogen. We are not discussing here IUPAC naming, right? We are just discussing a general method of naming the hydrocarbons containing functional group. So these are named by using prefix and suitable suffix, right? We will see the methods how we can name them. So when halogens are attached to a hydrocarbon, they are named as halo plus alkane. So it becomes haloalkanes. Right? For example, when we try to name chloroalkane, chloro plus methane, it becomes chloromethane. And the formula is CS3Cl. Because one chlorine atom is attached to the methane by replacing one hydrogen atom from it. So if bromine is attached to methane, it is named as bromo. It becomes bromomethane. So the hydrocarbons containing halogens are named using the prefix chloro, bromo, ido plus parent alkane So using this method, you can generally name the carbon compound, that is hydrocarbons containing halogens. Now, the second group is alcoholic group, that is alcohols. The functional group is OH. It is named by replacing E of alkane and adding OL to it. It becomes alkanol. For example, if we are naming the alcohol containing one carbon atom, so it is methane, so it becomes, we replace E from methane and add OL to it as suffix, it becomes methanol. Similarly, if we are writing the name of the alcohol containing two carbon atom, that is ethanol, ethanol, we replace the E of ethene and add OL to it. It becomes ethanol. In similar manner, the alkane butane containing alcohol is named as butanol. Right? So we name the alcohol by replacing E of alkane and adding OL as suffix to it. It becomes alkanol. In similar manner, you can name the other alcohols also. Acid. Carboxylic acids are named by replacing E of alkane and adding OIC acid. So it becomes alkanoic acid. So the name of the acid containing one carbon atom is we replace the E of methane and add OIC acid to it as suffix. It becomes methanoic acid. Similarly, the name of the carboxylic acid containing two carbon atom is named by replacing E of ethane and adding OIC acid to it. It becomes ethanoic acid. Right? And so on. So, carboxylic acid are named by replacing E of alkane and adding OIC acid to it. It becomes alkanoic acid. If it is derived from methane, it is methanoic acid. And if it is derived from ethane, it is ethanoic acid. Similarly, propanoic, butanoic, pentanoic, hexanoic acid. You can name as per the number of carbon atom contained in it. Right? Now the next one is aldehyde. The functional group is CHO. In carboxylic acid, the functional group is COOH. So, aldehydes are also named in similar manner. We replace E of alkane and add Al to it. It becomes alkanol. Al. Right? So, if you are writing the name of first aldehyde, that is methanol. So, we replace E of methane and add Al to it. It becomes methanol. So we replace E of ethane and add Al to it. It becomes ethanol. Similarly, you can write butanol, pentanol, hexanol, etc. Now the last one is ketone. The functional group present in ketone is CO, and it is also named in similar manner. We replace E of alkane and add O and E to it. It becomes alkanone. Right? Now, it is generally represented as R COR, where R are called radicals, right? Or you can say alkyl group. So, what is alkyl group? Let me define it first of all, and then we will move further. Actually, alkyl groups are called radicals. Why? Because they are dissatisfied. And it is generally represented by a formula CnS2n plus 1. It has one hydrogen less than normal alkane. So that is called alkyl. Now, knowing about the alkyl is very important to understand the naming of ketone, alkyl. You must remember it. Alkyl. These are the alkanes containing one hydrogen less than normal alkanes, right? So these are the group of compounds containing one hydrogen less than normal alkane. It is represented by a general formula CnS2n plus 1. So if we use it, right, and take only one carbon atom, the number of carbon atom as 1, it becomes CS3. So it is called methyl group. Similarly, if we replace one hydrogen from ethane, it becomes C2H5, that is ethyl. And similarly, C3 for normal alkane it is 8, so C3H7 is called propyl. So, while naming ketone, we must understand that ketone start from 3 carbon atoms, right? It must contain at least 3 carbon atoms. So it is named as replacing E of alkane and adding ONE to it. So it starts from propane. We replace E of propane and add ONE to it, it becomes propanone. The next one is butane. So replace E of butane and add ONE and become butanone. In a similar manner, you can name the compounds containing the functional groups such as carboxylic acid, aldehyde and ketone. Since these functional groups contain carbon atom, you can see there is a carbon atom in carboxylic acid and in CHO also and in ketone also. So these are called carbonyl group. The functional group, you must note it down. The functional groups containing carbon atom are called carbonyl. carbonyl group. Why? Because they itself contain carbon atom. And we count this carbon atom while naming them. We will see a bit more about the functional group in homologous series, right? So we must keep in mind about these carbon atoms, right?